Every AI tutorial that you come across today is in Python. LangChain Python, Llama Index Python, OpenAI SDK Python. But here's the thing that nobody talks about. 80% of enterprise backends runs on Java. So who is building AI into these systems? That's exactly what Spring AI solves. And in this video, I'm going to show you how. If you're a Java developer right now, it genuinely feels that you have been left out of the AI revolution. Every cool demo, every new framework, every tutorial, it's all Python first. And the worst part, your team can't just throw away a Spring Boot backend and it's been running into productions for a year and rewrite in Python. That's not how the real world works. On top of that, even if you do find a Java SDK for, say, OpenAI, you immediately locked into one provider. That's not a portable abstraction. No way to swap OpenAI for Anthropic. That's a terrible position to be in. So the question becomes, what if there is a way to integrate AI into your existing Spring Boot applications using the same pattern you already know, with the freedom to switch providers whenever you want to? That's Spring AI. Spring AI is an official Spring project designed specifications for your AI integrations in Java application. Now, it draws inspirations from projects like LangChain and Llama Index, but it is not direct port of those. It's built from the ground up to feel like Spring. What does it mean in practice? It means that you get a portable AI that works all across the major AI providers. OpenAI, Anthropic, Google, again Bedrock, Olama for local models, and more. You write your own code once, switching projects just like a configuration change. Let me walk you through the 6 core abstractions that make it work. First, there is an open chat client. Think it like a web client for an AI. It's a fluent API that lets you send the prompt and get the response in the way it feels completely natural you had been using for Spring before. Second, advisors. These are the middleware chains for your AI requests. Similar how Spring AI security filters work, you can intercept, modify, and enrich your request before they hit the model. Third, there is a tool calling. This is where it gets really powerful. You can let the AI model call your Java methods directly. The model decides when it needs the real-time data and your code provides it. Fourth is the vector store. Spring AI gives you a portable API for vector databases. It supports over 14 different databases out of the box, from PG Vector to Pinecode to Redis. Fifth is the ETL pipeline. This is how you load your own document and data into vector store for retrieval augmented generation or RAG. 6. The structured output. This lets you map your AI response directly to your Java Pojo. No more parsing JSON strings manually. The beauty of all that it runs your Spring Boot auto configurations. You add a starter dependency, sets your API key, and you are ready to go. Same dependency injection, same annotation, same pattern that you have been using it for years. Alright, let's build something. I want to show you how ridiculously simple it can be to create an AI-powered REST API endpoint with Spring AI. Step 1. Add your dependencies into your pom.xml. You just add Spring AI OpenAI start. Spring Boot will automatically configure everything for you. Step 2. Set your API key in application YAML under Spring AI OpenAI API key. You point it to your OpenAI key. I'm using environment variable here, which is what you should do in any real project. You can write it here just if you want to learn and for a demo purpose first. Step 3, write your controllers. And this is the part that surprises most people. Here is the entire thing. You create REST controller, you inject chat client.builder through the constructor. Spring provides this automatically. In the constructor, you call builder.build to create your chat client instance. Then you go to a single get endpoint. It takes questions as a request parameter and the body is just 3 chained method prompt Start building the request, user.question, to set the message, and .call to send it to AI model, and .content to extract the response as a string. That's it. 3 lines of actual logic, no SDK initialization, no API client setup, no boilerplate. Just clean, fluent code that any Spring developer can read and understand immediately. Fire up the application, hit the endpoint with the curl on your browser, pass any question, and you will get a response straight from the AI model. Now, here is what I want you to appreciate. If tomorrow you decide to switch from OpenAI to Anthropic, you swap the starter dependency, change the config, and your controller code stays exactly the same. That's the power of portable abstraction. So let's recap what we have covered. One Spring AI integration for Java developers, done the Spring way. It is not a hack or a wrapper. It is an official Spring project and it has the first class support. 2. It's supportable across providers. You can swap the models, changing the single line of abstraction code, and that's a huge deal for any enterprise team. Third, you already know Spring Boot. You already know about 80% of it that you will be using Spring AI. The learning curve is minimal because you'll use the same pattern, same conventions, and the same auto configuration that you are already comfortable with. This is a lecture of a 12-part series where we are going to go from zero building to a full production grade RAG or a RAG applications with Spring AI. Every concept, every abstraction, hands-on with real code. In next lecture, we will deep dive into Chat Client API and we will explore the Fluent API in details, including the streaming responses, system prompts, and how to customize behavior per request. If you don't want to miss that, subscribe and hit the bell.